Hello. So, kids, I think this will be a lot easier if I read this to you. And if I stay true to form, I will never just stay directly with the reading. I tend to add little things as we go along. Scientific method asking questions. How many angels can dance on the head of a pin? This is a question that has been pondered over the centuries. Pondered, kids, means thought about. So let's get this set up a little bit better. Okay, how's that? All right. Can it be answered using the scientific method? Is it a scientific question? The goal of science. The goal of science is to answer questions about the natural world. Asking and answering questions is integral or important to the process of science. Scientific questions must be testable. Which of these two questions is a good scientific question and which is not? What is the age of our planet Earth? Well, kids, is that something that we can test? How many angels can dance on the head of a pin? I don't know, kids. Is that something that we can test? The first is a good scientific question. It can be answered by age dating rocks and by using other techniques in science. The second question cannot be answered using data. It is not a good scientific question. Scientific method. Scientists use the scientific method to answer questions. But really, kids, is there just one scientific method? Not really. The scientific method is a series of steps. These steps help scientists, or even just people like you and me, to investigate a question. Often, students learn that the scientific method goes from step to step to step in a specific order, like this. You ask a question. The question can be based on one or more observations or on data from a previous experiment. And then you do some background research, and then you create a hypothesis. Use your imagination and reasoning skills to do that. You conduct experiments or make observations to test the hypothesis. You gather data, and finally, you use logical reasoning to formulate a conclusion. In reality, however, the process doesn't always go in a straight line. A scientist might ask a question and then start doing some background research. During his question, he may discover that his original question needed to be asked in a different way, or that an entirely different question should be asked. As a result, he was brought back to the first step of the scientific method. A flow chart of how science works can be found at this address. And if you want to click on it, kids, I think it'll take you there. I'm not quite sure. Ask a question. Now let's ask a scientific question. Remember that it must be testable. We learned in the previous concept, the science explanations and interpretations, that the average global temperature has been on the rise. I think, kids, that's one of our bell ringers. Okay. Scientists know that carbon dioxide is a greenhouse gas, and greenhouse gases trap heat in the atmosphere. This leads us to a question. Is the amount of carbon dioxide in the Earth's atmosphere changing? Kids, can we measure this? This is a good scientific question because it is testable. And then, kids, you see here, well, in fact, I I think I can scroll down. Okay. And then, kids, you can see here where they've taken some measurements over the years. Now, how has carbon dioxide in the atmosphere changed since 1958? So, kids, here we are. Here's 1958 down here. Okay. And kids, this goes up to 2010. Well, kids, I'm going to guess and say that it keeps going up. What do you think? Okay. So, how has carbon dioxide in the atmosphere changed since 1958? The line is going up. So carbon dioxide has increased. And kids, in fact, it continues to go up clear out here. Okay. And how much has it increased in parts per million? Well, kids, this over here tells you that these are measurements in parts per million. And so you would take from 2010, let's say 2012, kids, you would take this measurement. What is that? About 380, maybe let's just say 400 minus, what is this one down here, kids? Three, yeah, let's just say 320. So what's 400 minus 320? And kids, hopefully you'll come up with it's gone up by 80 parts per million. Okay, so about how much has it increased in parts per million? So we've answered the question. We use the data from the research that's already been done. Somebody else got to have all the fun taking these measurements. We just get to read about it. Fortunately, scientists have been monitoring CO2 or carbon dioxide levels over the years. If they hadn't, we'd have to start these measurements now. Because this question can be answered with data, it's testable. And if something is testable, kids, does that make it a good, strong science question? I hope this helped, kids. If it does, let me know. If it doesn't, let me know that too and tell me what I need to do to help. Thanks. Bye-bye.